last year in Algebra 2, so it's something kind of new. But I don't think it's that terrible once you get past the fact that it's different and new. We're actually breaking this up into 2 days, and this is called parametric relations and inverses. Well, today we're just working on the parametric part, and then tomorrow we're going to talk about inverses. But everything we've done up to this point in math, we've always just dealt with two variables. We've had the x and the y. The x tells you the horizontal change. The y tells you the vertical change, which tells you at any point where that graph is. But what it doesn't give you is what's happening over a specific amount of time, and that's what a parametric relation is it kind of throws in this third variable. And so I'm just going to graph, hopefully a graph that we're all familiar with, the graph y equals x squared, which is a parabola. Kind of looks something like that. If I asked you, when x is 3, where's that graph? You would plug 3 in and you would say, oh, it's up at 9. And that's what we've always done. If I asked you after so much time, where's that graph? We don't know, right? How long does it take to get from -2 to 2? There's no time value in that. But what we can do is define that in terms of a third variable. And that third variable we usually call t for time, and that third variable is called the parameter. And basically what a parametric equation does is it lets you graph some kind of maybe complicated graphs, maybe graphs that aren't functions, and graph them in a new way. And your calculator actually graphs parametric equations, so we'll get to that eventually. So I have a little bit of definition stuff for you, and then we're just going to jump right in. I feel like the notes are pretty short today, which is good for Python. We're going to get past the definition part. Are we good? Okay, so here's kind of the definition of a parametric equation. A parametric equation has two equations. It has x equals something in terms of t. So we say x equals f of t. And y equals another equation in terms of t. So we say y equals g of t. And those are called parametric equations for a specific curve. And again, t is called the parameter. We could actually say that, well, I'll explain it for that. And when we're sketching this, these are kind of my directions here. There's only 2 steps here. We're still going to graph on the xy plane. Like, it's still going to just be an x and a y. We're not going to throw in a third axis or anything. But what we are going to do is we're going to graph them in order. So it says plot in order of increasing t values. And what that does is it gives you like the direction that the curve is going. And I'm going to show you how you can draw arrows in on your graph to show that the direction that the graph is going in. And so we can sketch this with t in the problem, and I'm going to show you how we can do this. The other thing that we want to do with parametric equations, one is we want to be able to graph them. The other thing is we want to be able to write it without t, write it the way we're used to. And the directions for that is it's going to say eliminate the parameter. That means write without t. Eliminate t, which is the parameter. And sometimes it's easier to graph when you eliminate the parameter because you get back something that you know how to graph very easily. To my last like definition stuff here, then we'll start the examples. But basically, you're just going to do substitution. If you have two equations, both that have t in them, you can just do substitution. You can solve for t in one equation, substitute it in the other equation, and you're going to get rid of t. And once we do that, I think it'll make a lot of sense. So I try to just pick a few different problems that are similar to what you have on your homework today. And so you can get used to the directions. Because this is new stuff, the directions are going to be a little bit different. Yeah. Midterms. All right, so it says find the ordered pair, find the xy pair for the value of the parameter, and they give you the value of t. And so I put t equals -3. And notice they give you two equations. Parametric equations always come in pairs. There's an x equals and a y equals. Yeah, all you're doing is plugging -3 in, and what you should get out of that is you should get an x value and you should get a y value, which means when t is -3, you could figure out where is your graph. Like you could figure out what point that is. And that's all this is saying. When t is -3, I can plug that in here, and I could get x equals -3 plus 1, which I hope we all agree is -2. And same thing for this one. We have to plug in for the y also. So I'm going to get y equals -3 squared plus 2 times -3. Which would be 9 minus 6, which would be 3. With graph, we're going to do the same thing. We're just going to do this for more than one point. But when t equals -3, the ordered pair would be what x and y are, which is just -2 and 3. This is what you graph. You don't graph the t part. But you're not graphing this one anyway. I think that's the first part of your homework today. Not so bad. Questions about that? We're not sketching this one, because it's just one point. We're going to sketch an entire equation in a minute. Okay, let's get to the equation sketching part. This is the majority of your homework today. It says, sketch the curve by eliminating the parameter, indicate orientation, and I'm going to show you what that means. And we're going to use the values from -2 to 2 for our t values. So I want to show you how to graph it without eliminating the parameter first, and then I'll show you to eliminate the parameter, and we can talk about which way makes more sense to graph when we're doing this. Normally we have an XY chart. We pick the X values, we plug them in for the Y. With a parametric equation, you start with the T values, just like the last problem, and you plug T in and find your X and your Y. So instead of having an XY chart, we're actually going to have like a T XY chart. We have 3 variables. I'm going to check on your homework. I think they tell you what to use for T, like I did here. Because otherwise you don't really know what to, like where to start. And I'm going to pick values from -2 to 2. So I'm going to pick -2, -1, 0, 1, and 2. And just like we did on the last example, if I gave you t equals negative 2, you should be able to plug that into that problem and tell me what does x equal, what does y equal. And a lot of times it doesn't take a whole lot of calculation here. But if I plug in negative 2 for t, negative 2 plus 2, do you agree that that's going to be 0 for x? And if I plug in negative 2 for y into the y equation, y equals negative 2 squared, do you agree that's 4? So go through and fill those in. Plug in negative 1 for t into x. Plug in 0 for x. I tend to do all the x's first and then all the y's, but that's just my way. Everyone with me on those points? Getting those points? When you're graphing this, you just graph the xy. So basically what we have here are a bunch of ordered pairs. Remember, should be 3 here, 4, 4. Sorry, my points don't line up very well. We want to graph in order because we're going to put the orientation on here. But if I graph these 0, 1, 2, 3, 4, 1, 1, 2, 0, 3, 1, and 4, 4. You're exactly right, Logan. It's a parabola. The difference between a normal equation and what we've just graphed is we're only going negative 2 to 2. So we're not going to put arrows on the end of this because we're only giving the answer from negative 2 to 2. So I'm going to draw my little graph in here. To show the order that we're going here, start with your first point, and it's going in this direction, right? So we're just going to put little arrows on that to show that. So we're going to kind of put an arrow here, and an arrow here, and an arrow here, to show that this was the direction that we graphed those points in. That's what it means by the orientation. So whatever order you graph your points in, that's how you put your little arrows on. You can put this back together as a regular equation, and it should look like a parabola. To eliminate the parameter, we want to put this back together so that we can have no t in our problem. Which one of these looks easier to solve for t, the top one or the bottom one? Yeah, pick the easiest one to get t by itself. There's no need to take the square root here. To solve this for t, could I just subtract 2 over and say t equals x minus 2? Everyone agree with me on that? And if I'm trying to get t to go away, and t equals x minus 2, can I plug that in for t in the y equation, and that gives me a problem with just x and y and no t? That's what it means to eliminate the parameter. So I'm going to take this, and I'm going to plug it in right there, and I get y equals x minus 2 squared. And you don't have to FOIL it out. You could if you want, but that's definitely going to be a parabola. We're going to talk about transformations in section 1.6. When you subtract 2 inside, it actually means that it moves left, right 2, and that's why that parabola is shifted over 2, but we'll get there. But that's eliminating the parameter. You could also have graphed it from there, and then you don't have to use t. You can actually just pick your points and plug them in. Why would you do that? I don't know. I feel like plugging t in makes things really easy also, but sometimes it's not such a pretty equation. Sometimes it's going to be a parabola on its side. Remember those equations? We did those last year, conic sections that open side to side. Sometimes it's going to be x equals y squared, which is a parabola that opens on its side. Sometimes it's going to be a circle. Like, it's not going to always be a graph that we're so familiar with, which is why sometimes it's easier to work like this than to work with this. Later on down the road, next semester when we learn trig stuff, we'll graph parametric equations that are like rose petals, and they look like a rose when you graph it. Not really a rose, but they call them rose. And that's definitely easier to use the x and the y than to use the other one. Let's do one more that's not so pretty. Same directions as the last one. So we're going to make our little XYT chart. Then we're going to eliminate the parameter, and we're going to graph that. So that's what it says on your homework today. There's like parts A, B, and C. Part A is make a little chart. Part B is eliminate the parameter. Part C is graph the equation. This one's definitely one that, I don't know which way you want to do it, but I feel like using the XYT chart isn't so bad. Or TXY chart, I guess I should say. Oh, this one we get some not so pretty ones for y, so just kind of keep that in mind as you're plugging your numbers in. So for y, you have to do a little bit of work on this. But you would get like negative 2 over negative 2 minus 1 would be negative 3. So I think that would be 2/3. If I plug negative 1 in, I get negative 1 over negative 2, which is 1/2. If I plug 0 in, I'm just going to get 0, right? 0 over negative 1. If you plug 1 in there, you get 1 over 0. Right? 1 over 0 is not 0, it's undefined, which means there's going to be no point there on our graph. And when we eliminate the parameter, we should be able to see maybe why that's going to be undefined. And then if I plug 2 in, I'm going to get 2 over 1, which is just 2. Let's go ahead and eliminate our parameter to see what our equation would be if it just had x and y in it, and maybe that will help us when we're graphing this to know what to put here. Which one of those looks easier to solve for t, the x equation or the y equation? Definitely the x equation. The y equation has 2 different t values in it, and there's a fraction. It'd be a really big mess to solve that one for t. But to solve this one for t, I could just add 1 to both sides, and I could get that t equals x plus 1. So just like before substitution, I can just replace both of those t's with x plus 1, and I'm going to get y equals x plus 1 over x plus 1 minus 1. Eliminate the parameter, make t go away. You with me on that? I think I can make that look a little nicer there. 1 minus 1 is just 0. So I think I'm going to get x plus 1 over x. Is that right? So look at that point that was undefined. When x is 0, there is no y value. Why is it undefined when x is 0, looking at this equation? You can't have 0 in your denominator. The domain would not include 0. And could we even say there's an asymptote at x equals 0? the bottom equals 0, that's a vertical asymptote. So that's why that's undefined. So we could say there's a vertical asymptote at x equals 0. Looking at this equation, could you tell me if there's a horizontal asymptote? We went through those rules talking about the degree of the numerator and the degree of the denominator. I think that was back in like section 1, 2 or something. What would the horizontal asymptote of this be? It would be 1 because the numerator and the denominator are the same degree, so I take the leading coefficients. So I could even say that there's going to be a horizontal asymptote at 1. So that should kind of help me when I'm making these points on here, but let's see. So remember, we're not graphing the t-values, we're just graphing these ordered pairs here. Only I can't graph undefined. At -3, I'm at 2/3, which would be not quite to 1. At -2, I'm at 1/2. Should be a little bit lower than 2/3. At -1, I'm at 0. And then at 0, I'm undefined, so I don't even have a point there. And then at 1, I'm up here at 2. Should have maybe made you pick one extra point on this one. But,
Are you laughing at the line?
no, you really have to do what they say when you're graphing it. But
Because it gets into the t-value.
right, it gives you the t-value, so that's what we're going to graph on these. But because this is an asymptote, I'm going to start here. And even though my point stops here, this actually keeps going all the way to 0. It's just undefined. So I need to show that that's an asymptote.
How do you know that's an asymptote?
Because we know that it's undefined at 0. We looked at the equation. We know that x whatever equals 0 in the denominator are my vertical asymptotes. That was my horizontal asymptote, yes. And so it goes back to all that stuff that we did back in section 1, 2, of knowing what it means to find a vertical and horizontal asymptote. If you have an x in your denominator, you're going to have a vertical asymptote. And that's why it's at 1, because x over x, 1 over 1. I can put my little arrows on this to show that I'm going in that direction. Same thing with this one. I'm not going to go past this point 1, 2. Technically, if we picked more points, but we're not going to because we're only following the rules here. This is going to keep going out here, but I'm not going to go that way because I'm stopping at that point. But again, between 0 and 1, what's happening? Well, it's going to get closer and closer to that asymptote, and so I can show that it's getting closer and closer to that asymptote, and I can put little arrows on that too to show that I'm going towards the point 1, 2, and I'm stopping there. You're definitely going to see some other graphs on your homework tonight, like a sideways parabola, which we did last year, but it's been a while. Use the chart to help you, right? And eliminate your parameter and look at your parameter or what you get when you eliminate it to try to help you figure out if your graph is right. You shouldn't get something crazy. If you get a graph and like you have points all connecting and then you have a crazy point off and then it's back connecting, that probably means you did the math wrong because it should be a nice little graph when you're doing this. Really easy homework assignment today. 1 through 6 all. You actually have some time to work today, so you need to get your homework out and start on that. Remember that you do get participation points in here. If you're not taking notes or you're sleeping during notes, you're going to lose participation points. If we actually have time to work on homework and you choose to not work on homework, you're going to lose participation points. So make sure you keep that in mind with the decisions that you make. Also, it's a great time if we have time to get started. So if you need help, that you can ask me now.